All right, 3.5 video notes, finding slopes of lines. Ultimate goal of this section is we need to be able to prove or show that two lines are parallel or perpendicular, meeting at 90 degrees, and doing that, the slopes are key. So we need to find out how to find the slope of a line given a graph, given 2 points, given an equation, and that's what we're going to tackle today. All right, so let's jump into this. First idea here is, what is slope? Slope is basically the steepness. It's how steep something is. And a lot of kids, look at that and say, well, that's rise over run. And they're actually right. Technically, though, it could be fall, because you don't always rise. Sometimes you fall. So another way to look at this is the vertical change over the horizontal change. So it's a ratio, it's a fraction that can be written down. One thing you want to know is we're always looking from left to right. So we're going to go from left to right when we view these lines. So if a line is increasing from left to right, we say that it has a positive slope. And a line that's decreasing from left to right, we say has a negative slope. So those are just some key points that hopefully you remember from algebra. All right, so finding slopes of graphs. Number one, first thing you need to do is you need to find 2 points on the line. And the points that we're really looking for are what's called lattice points. Okay, lattice points are where it crosses perfectly across two corners. So for instance, looking at this first one, I think right there is a good lattice point. It crosses right perfectly at that corner. And then as I move on down the line, the next lattice point appears to be right here. So now that I've got 2 points locked down, I want to be able to try to find the vertical change and the horizontal change. So moving from left to right, you always want to go left to right. It looks like we went down 1, and then we went right 3. So down 1, right 3. So my slope then is going to be down 1, right 3. I know it's negative because the line is decreasing from left to right. So moving over here to the next example, finding 2 lattice points. I don't know, the first one my eye saw was right here. Moving up, moving up, moving up. It looks like right here would be the next one. And I already know this one's going to be positive because it's increasing from left to right. And it goes up 1, 2, 3, 4 blocks up, 3 to the right. So this line has a slope of 4/3. Now, slope, usually we define slope as the letter M. That's how we express it. So sometimes you might see that M equals 4/3. M is just the lowercase letter that we often use for slope. All right, moving right along, going down. We have a couple more. These are kind of what I like to call the freak cases. So the freak cases, there's always kind of a few cases where weird stuff happens, are both of these. So for instance, I see a lot of lattice points here. I could look here, and maybe I just pick another one over here. Well, when I set up my rise over run, there is no height change. There is no up or down. It's 0. And then on this particular 2 points, it runs 4. And if you punch that in your calculator, 0 divided by 4, you will find out that the slope is 0. So it does have a slope, it's just 0. So it might be easier to remember that anytime you have a horizontal line, then you're going to have a slope equal to 0. All right, that's just kind of a rule that you need to remember. Equation-wise, the equation of this blue line here, when it has a 0 slope, you don't see an x component. So it's y equals, this line would be an example of y equals -3 because it crosses right here at -3. All right. So whenever you see that the line is missing an x, it has a slope of 0. So slope of 0 is when you're missing an x. All right, now the other case, the other extreme case kind of from that is a vertical line. So for instance, let's just pick 2 lattice points. I'm just randomly picking 2 points on the line. Well, in this particular case, this line rises 1, 2, 3, 4, 5, but it had 0 horizontal change. Now, if you punch this into a calculator, you're going to get an error message because you're not allowed to divide by 0. So this is what we call the slope is undefined. So M is undefined. So all vertical lines have an undefined slope. And those equations, for instance, the equation for this line over here, that's going to be x equals 3. So it's missing a y component. There is no y component for those lines. Sometimes people say instead of undefined, they also might say that there is no slope, okay, which is a big difference from that. That one has a slope, it's just 0. But vertical lines have no slope. So there are the graphs. Let's move on down now and let's take a look at when I'm given 2 points. You're probably familiar with this maybe from algebra last year. And you're given 2 points, and let's just kind of go the hardcore way. You know, this is my first XY pair, so I'm going to call it X1, Y1. This is my second order pair that was given, X2, Y2. And if you looked up the equation for slope online, you're going to see that you subtract the y's, which basically is just finding the vertical height, and then you subtract the x's. And the key is you have to go in the same direction. So if you start with the second order pair and subtract the first, you have to keep that going for both pieces. So let's just kind of put the values in. So y2 take away y1. So y2 take away y1 divided by x2 minus x1. And be very careful here. x2 minus, and then I can't forget that negative sign. I see a lot of kids screw that up. And when I work out the math there, 2 minus 5 is negative 3. And 4 minus a negative 3 is really the same as 4 plus 3, which is positive 7. So remember, if you're doing this by hand, we never subtract. We always add the opposite. And we add the opposite. So that's how I got those numbers. Now, if you end up with a negative on top and a positive on the bottom, you can just pull that out to the front. So this line has a slope of negative 3/7. All right? And then if you put those 2 dots on the graph, you should find that you basically go down 3, right 7 to get from one point to the next point. That's kind of the pitch that they were talking about there. All right, let's do the next one. Find the slope of a line containing the points negative 6,3, negative 6,5. So another method number 2. So some people call this the slope slide. I just learned it last year, so this is really kind of new to me. But you stack the 2 points. Instead of putting them horizontal, you stack them. So I go negative 6, 3, and then negative 6, negative 5. I guess why people like this is because your x's and y's are already lined up for you, so maybe it's easier to subtract. And the slope slide, you kind of come down and then you go to the right. And what that does is it forces your y's to be on top. So if I actually do the math here and I do 3 take away a negative 5, and then the x's, I have negative 6 take away a negative 6. And when I work my math out, add the opposite, add the opposite. Oh, and I see that this one is undefined. So this slope here is undefined. All right, so let's go to the next page where we have some equations here. Find the slope of a line when given an equation. Kind of make this go down so that it kind of fits in on the right page. Looks like it bumped up on me. There we go. Looks a little better. So find the slope of a line when given an equation. Some of these are written already in really nice form. Like for instance, these first 3 are in what's called slope-intercept form. So if you're in y equals form, that's in the form of y equals mx plus b. And remember, the m, the letter that's in front of the x there, that represents our slope. So these first 3 are really quick and easy. I can just kind of be like, hey, this equation, the slope, or m, equals 3. The second one here, that's a negative x, so we pretend that there's a 1 there. So this one has a slope of negative 1. When I look over here, this is in y equals form. So this has a slope of negative 2/3. So those are really nice. They're really fast. They're easy. The beautiful thing is you can see the slope. You can also see, we're not going to be messing with this right now, but you can also see the y-intercept where it crosses the y-axis. Now the next group down here, these are what's called standard form. All right, and anytime you see something in ax plus by equals c format, you know, and a, b, and c are just the numbers. So for instance, you know, 3 is our a, positive 3 is our b, 10 is our c. Anytime you see it written like that, that's called standard form. And those require a little bit more work. All right, so we need to do some rearranging. We need to rewrite the equation so that it's y equals. So we have to solve for y. So what I'll do here on this first one, to get y by itself, I'm going to subtract 3x from both sides. And when I do that, I'm left with 3y equals, and I'm going to put the x term in the front just because in slope-intercept form the x term is up there in the front. And I'll put that positive 10 at the back. And then my last move is I need to divide everybody by 3. So now we have y equals a negative 3 divided by a positive 3. Well, that's a negative 1x plus 10 over 3, or you could change that to a fraction or a decimal if you'd like. But I'm more concerned with what is the slope. So now I know the answer. The slope of this problem is negative 1. Now we'll try it again over here on the next one. So I want to get y by itself. So I'm going to need to minus the 3x, minus the 3x. And I do that, and I get 2y equals negative 3x plus 8. And I divide everybody by 2. Divide by 2, divide by 2, divide by 2. And I get y equals negative 3/2 x plus 4. So now I can see the slope. The slope is a fraction. It's negative 3/2. And I'll do one more here. So on the last one, I move the x to the other side. I slide this negative 2y down. And then I divide both sides by a negative 2. And my new equation is y equals, a negative divided by a negative is just a positive. And now I can find the slope for this line. Now, you're going to need this here in a second, but I have now found all 6 slopes up top here. Okay? And we should be able to look at those lines, and some of those lines are parallel to each other, some of those lines are perpendicular to each other, and some of those lines are neither. All right, so what's true about slopes of 2 lines that are parallel? Well, lines that are parallel, so parallel lines have the same slope. Okay, they got to be the exact same. So both slopes, if one line has a slope of 3, the other line has a slope of 3. So for instance, you can kind of, map this out and say, well, if I'm going to go up 3 over 2, and here's my 2 dots, on my line, a line that's parallel to him somewhere else, 2 lines that never touch, is also going to go up 3 over 2. They need to be identical. Both those lines would have a slope of 3/2. Now, perpendicular is a little bit tougher. Lines that are perpendicular, a couple things we need to know about their slopes. All right, perpendicular lines, I'm going to use a symbol. Perpendicular lines, slopes are opposite reciprocals. Okay, opposite reciprocals. Okay, meaning that one's positive and one's negative. So the opposite part means They have to have different signs. One's going up, one's coming down. And the other part is they need to be flips of each other. All right. So for instance, let's say that one line has a slope of 3/4. Okay. So let's just say this is a slope of line number 1. Well, if it's going to be perpendicular, line number 2, I have to flip that fraction and I have to change its sign and make it negative. All right. So that would make sure, this would ensure that line number 1 is perpendicular to line number 2 because I analyze their slopes. I'm like, yeah, one's positive, one's negative, and they're reciprocals, or they're flips of each other. Now, if you're looking at, let's say that one line has a slope of, let's say, 2. So let's say that line number 1 has a slope of 2. Then if I want to be perpendicular to him, if I want to be perpendicular to that guy, I got to kind of change this to 2/1. And so then my other line is going to be the flip, and then it's going to be opposite. So basically a line with a slope of 2, his perpendicular buddy would have a slope of -1/2. All right. Now, kind of another interesting fact between these two is that if you multiply them, you should get a product of -1. All right. So I can test this and say, well, back to my original example, if I do a slope of 3/4 and I times it by a slope of -4/3, you should always get the answer of -1. For instance, this would be -12/12 or -1. That's always going to happen when two lines are perpendicular. You can just multiply their slopes together. Be sure you get -1. All right, look at the 6 equations above to answer the following questions. So we're trying to find 2 equations that are parallel to each other and 2 equations that are perpendicular to each other. All right, so if we go back up and we look at the equations at the top, and I'm just going to write them over here to the side since my sheet here doesn't really have all that on there. Just kind of go up a little bit. All right, so look at the 6 equations above and answer the following questions. Write 2 equations that are parallel. So remember, parallel, I'm looking 2 equations that have the same slope. And then 2 equations that are perpendicular. So I'm looking for opposite reciprocals. All right, well, I'm going to write the equations over here to the side. So the first equation was y equals 3x minus 4. And this line had a slope of 3. The next equation was y equals -x plus 3, which that had a slope of -1. The next one was y equals -2/3 x minus 2, which had a slope of -2/3. And then we got into the ones that we rewrote, and 3x plus 3y equals 10. That one had a slope of -1. The next one was 2y plus 3x equals 8. And his slope was, move it over, that'd be -3/2. -3/2. And then finally our last one was 3x minus 2y equals 8. And his slope was +3/2. All right, so we can look at these slopes and let's try to figure this out. So for this first one, who has the same slope out of the group? Well, I think this equation has a slope of -1. This equation has a slope of -1. So these two are definitely the two that are parallel to each other. All right, those two lines are going to run parallel. Perpendicular, I'm looking for slopes that are both opposite, meaning one positive, one negative, and reciprocal. And this one's a little bit trickier, but it looks like right here we have a -2/3, and if we flip it and change the sign, right here we have a +3/2. So those equations are the two that are going to be perpendicular to each other. This one was kind of close. These two are close, but not quite, because they're not opposites. They are flips of each other, but they were both negative, so that one couldn't work. So hopefully you have an idea now of finding slopes, whether you're given a graph, whether you're given points, whether you're given an equation, and you should be able to identify whether they're parallel or perpendicular to each other.